Okay, so what we're going to do today is we're going to talk about graphing inequalities. And it can actually be very, very, very simple. Students that struggle with graphing inequalities are not necessarily struggling with the math, they're struggling conceptually. So I want to make sure that we're solid here. And I'm kind of taking this question from a program. So we don't really even need to pay too much attention about all this wording. Um, this is really just helping you identify if you were to plot this on a program, what the directions would be. But it was a cleaner version for me to give you some examples that were already graphed. So what we have here is we have graphing x is less than 6. And before we do that, we want to always think about this. We are required to have the variable written on the left. And the reason for that is this inequality. Some students are going to have a very difficult time remembering which one's the less than sign, which one's the greater than sign. So there's kind of a nice little cheat sheet here that if you have always written the variable on the left, this inequality will be pointing in the direction you need to graph. So that's one of the concepts we want to think about. Always write the variable first, and if you have done that, this inequality will be pointing in the direction. So I know I'm going to the left. I'll be taking and shading to the left because that's the direction that inequality is pointing, and that will help you identify whether what a less than or what a the greater than sign is. And the second thing I want to look for is there an equal sign underneath of this? And there isn't. So what we're going to do is we're going to graph this. So we're going to start at the 6, which is over here, and I'm going to put a point. Now, if I leave it like that, I'm saying I get to include the 6. But because there's no equal sign here, I want to put an open circle there. That says I get to start from 6, but I'm not going to include this number. And then I'm going to graph to the left because that's the direction that's pointing. So I'm graphing to the left. And now we can take some numbers. Notice that the x is less than 6. All of these numbers here are the x values. We can pick a few of them up and see if it makes sense. Let's throw in a 0 and say, is 0 less than 6? Well, yeah. What about the 3? Pick up the 3 and put it in. Is 3 less than 6? Absolutely. So we know we've graphed it in the correct or in the right direction. I should say the correct direction because this was actually left. And by just checking some answers. All right, so let's look at another example. In this example, we're going to graph x is greater than negative 6. But again, some of you are going to struggle and it's going to take some time to be able to look at that and just say greater. So I'll always going to remind myself variable must be written on the left. Okay, well, it is. So that's check. Second thing I look for, is there an equal sign? No. So let's go to the negative 6 and start here. Again, if I left it like that, I'm saying I get to count this number. And the only time I can ever count this number is if there's an equal sign right there. So we need to open circle. And then because the variable was written on the left, this inequality is pointing in the direction I want to graph. It's pointing to the right. So let's graph this to the right. And we can grab a few numbers and just check. Let's grab the 0. It's a nice, easy one. Throw a 0 in it right there and say, is 0 greater than negative 6? And it is, right? 0 is greater than negative 6. Negative 6 is like owing somebody money. So technically, if I have 0, I have more than a negative number. So that works. Let's look at another one. Okay, again, I'm going to keep reminding myself, variable must be written on the left. It is. But in this case, there is an equal sign. So again, there's always two things I'm looking for. Is there variable on the left? And is there an equal sign? So yes on the variable on the left and yes, equal sign. So let's go to the negative 56 and start here. And I get to keep this closed. The first two examples, I had to do an open circle. This one gets to stay closed because it actually can equal this number. And because the variable was written on the left, this is pointing to the right. So let's graph it to the right. And again, you could grab a number here. Matter of fact, this thing is actually pointing to 0. Like 0 would be way over here. You could still throw a 0 in there. Any number to the right of negative 56 And 0 would be greater than a negative number. 5 would be greater than a negative number. Any number to the right of this is greater than negative 56. Excuse me. All right, let's look at another one. Variable is written on the left, so check. Is there an equal sign? There is. So I know I can start at negative 30 and do a closed circle. Now I kind of like this example because most of the time when we graph, somebody's always graphing it from the middle of the line. But this one's at the very end. And that inequality is pointing in what direction? Well, it's pointing to the right. So we actually have to graph that way. That is the answer to this problem. Technically, if you were doing this, say, in a classroom for your teacher, you would want to add another number. So you'd maybe put negative 29 here, just so you could see when you're graphing inequalities, you want to put numbers on both sides of where you're starting to plot the number from. But that is the direction we're going to go, and that is the graph. That is the solution set, every number to the right of negative 30. Every number that is greater than or equal to negative 30 is a solution to this problem. All right? So go ahead and pause the video and see if you can graph that. Okay, so we wanted to say, is the variable on the left? Well, it is. So that's handled. Second question was, is there an equal sign? No. So we should have started at 345 and closed the circle, or I'm sorry, and not a closed circle, but an open circle, because we don't get to count this number. And then what direction am I supposed to graph? Well, it's pointing to the left. So we needed to graph it that way. All right? All right, so I've given you a couple examples of where this statement is not true right away. The variable must be written on the left. It is not currently that way. So what we want to do here is we want to take the x and write that here. We want to take this 3 and put it here. And the easiest way to do this is notice that this inequality is currently being pointing at the x. I just want to keep it pointed at the x. So when I rewrite it, that's how I do it. I grab that x and I write it first because that's the requirement. I grab the other number, I put it on the other side, and then I just ask myself, well, what is the inequality pointing at? It's pointing at the x, so I kept it pointed at the x. And then we can say, well, this is x is less than 3. We can start at the 3. There is no equal sign. We can close that circle. And because the variable was written first, it is pointing in the direction I need to graph. It is pointing to the left, so I will graph it to the left. Okay? We'll do one more of these. Again, always asking this question. Variable must be on the left. Well, that's not the case. So let's grab the variable, put it on the left, grab the negative 1, put it on the other side. And again, this inequality, which has an equal sign, this inequality is pointing at this x. We want to rewrite it where it's still pointing at the x. And we can say x is less than or equal to negative 1 when it originally was written as negative 1 is greater than or equal to x. And where do we get to start? Well, we're starting at a negative 1, so we should be starting here and ask ourselves, do we get to count this number? Yes, we do. What direction is the inequality pointing? Well, it's pointing to the left. So there's the graph of this inequality, but that is the appropriate way to write it. All right? Nice job.